So the 1.3 lecture, let's take a look at the notes first. Shifted geometric sequence would be u sub n equals r times u sub n minus 1 plus d. So it's got a common difference and a common ratio in the same problem. At first it probably is confusing because we're doing what looks like a geometric and arithmetic at the same time. But this allows us to do different types of problems. Also in this section we need to know how to find a long run value, which is the limit. You really study limits when you get into calculus, so this is laying a building block back in Algebra 2 already for limits. So a shifted geometric sequence will eventually level off at a certain value. So we're going to take a look at that also today. So after writing down some of the notes, we can look at a problem where the Osborns have a small pool and they're doing chlorine treatment. So they haven't been using the pool lately and now they need to shock it, which is adding way too much chlorine, but it starts the process of cleaning the water. And we can model this with a shifted geometric sequence. So you notice that the u sub 0 is the initial amount of chlorine that they put in, measured in grams, so they put in 300. And then we can do the 1 minus 0.15. So you'll notice this is a p-value, what I would call the percent change in the problem. Or in this case, you could also think of it as r equals 0.85. They'll be adding 30 grams every day. So to determine what happens to the chlorine level in the long run, let's look at a calculator. So we're going to start at 300 and we're going to multiply that. I'm going to leave it in the parentheses form where we said 1 minus 0.15, and we're going to add 30 grams. So the first couple times I do this, you can just hit enter. You'll see that the numbers are decreasing, but you'll notice that the first gap, the first time we lost 15 grams from 285 to 272 is about 13, 272 to 261 is about 11. So the gaps between our numbers are getting increasingly smaller. You just keep hitting enter, 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 enter. Do it as fast as you can, as fast as the calculator will go. And eventually you start to notice that 201, 201, 200, 200, 200. A faster way to do this is to take your common difference number 30 and divide by the p-value in the problem, and that will also generate the long-term value. So you can do it with the calculator, which you saw me do, or the algebraic method that we just looked at. We can do the same sort of problem with medications. So if you read the problem, our body is going to metabolize 10% of the drug every 8 hours, and we know that the drug works best when it's at 1,000 milligrams. So initially we're going to take 100 milligrams. So our initial amount is 100. The recursive formula, the rule for it will be take your last amount times 1 minus 0.1 plus we're going to take another 100 milligram dose. So again, if you would put this on your calculator, we're going to start with 100 grams So hit enter on that. Then we're going to multiply. Again, I'm going to stick with the 1 minus 0.1 plus the 100 milligram dosage. Now when you hit, that's the first 8 hours, second 8 hours, third set of 8 hours. So that's 1 day. And so what we have to do is 4, 5, 6. So on this particular problem, we're getting about 521.7, but that's U sub 6. 521.7. And if we calculate the long run value, we'll just call it the 100 milligram dose divided by the 0.1, which is the p-value. So the 100 milligrams is what we're adding each step. Oops, we're dividing by 0.1, and you'll notice that you get 1,000. So eventually, we do get to the 1,000, but if you do it on your calculator, you'll see how long it actually takes you to get the patient to 1,000. We will finish this example in the next video, 1.3 part 2.